So the setup is we're going to use a drug that hopefully you're not all that familiar with, so you can get comfortable with the idea that the math is the math regardless of the drug. So I picked N-acetylcysteine, or the brand name Mucomyst, which is for acetaminophen overdose. And we're going to take a look at the dosing, which is right down here. 150 milligrams per kilogram IV over an hour, and then we step down to 50 milligrams per kilogram for the next 4 hours, and then we step down to 100 milligrams per kilogram over a 16-hour period. The first thing I do is pull out the reference card that I always have on me in the ambulance to see if there's a formula that is the logical choice for this calculation. When I look at the dosing orders, that first one looks a little bit like 150 milligrams per kilogram per hour. And if I wanted to calculate that first infusion using that formula, it would work. But then when I move to the second and third stages, it no longer works because it's not expressed as milligrams per kilogram per hour. Now it's milligrams per kilogram spread out over 4 hours and then spread out over 16 hours. Since that's the case, I recognize that the correct formula to make this easy is fluid over time. With the fluid over time formula, the only complicated part is figuring out what the total volume is. I have to figure out how much volume it takes to get 150 milligrams per kilogram, and then 50 milligrams per kilogram, and then 100 milligrams per kilogram. A very helpful nurse who understands that you're practicing your medication math hands you a vial of acetylcysteine, which contains 6 grams in 30 milliliters. She also hands you this bag filled with 250 milliliters of D5W. If we put this entire vial of 6 grams of acetylcysteine into this bag of 250 milliliters of D5W, how many milligrams is in that bag, and what is the concentration? You can press pause here if you want to do the math yourself and then come back and see if you got the answer correct. Hopefully you remembered that 1 gram equals 1,000 milligrams. So 6 grams is 6,000 milligrams in 250 milliliters. 6,000 divided by 250 should get you a concentration of 24 milligrams per milliliter. So how much does this patient weigh? Let's pick a random weight for this patient. So we're going to say they weigh somewhere between 75 and 150 kilograms and press the random generator, and we got 103. That's going to be our weight. And we also know we're probably from Wisconsin. And now we should have all the information we need in order to plug these numbers into our fluid over time formula. Let's set it up and do the math. For the first dose, the first number that we have to calculate is the total volume, which is going to go right here. That's asking how much of this 24 milligram per milliliter fluid do I have to give in order to achieve the dose of 150 milligrams times 103 kilograms. You can press pause right now if you want to calculate the total volume for the first dose. If you multiplied 150 milligrams times 103 kilograms, you should have come up with 15,450 milligrams of drug. When you divide that by 24, you should have a total volume of 643.75 milliliters. We're going to plug 643.75 into the formula. We multiply by 60, which is the drip factor. But if you remember, drip factor of 60 is exactly the same as milliliters per hour on a pump. Very convenient number there. And then we're going to divide by 1 hour or 60 minutes. And so we wind up with 643.75 milliliters per hour for that first hour. Therefore, for the first stage of dosing, we're going to program our pump for 643.75, and we're going to run it for 1 hour. Do you think you can figure out the second stage of dosing? If you can, press pause now, calculate it up, and then come back when you have your answer. For the second stage of dosing, we want to multiply 50 milligrams times 103 kilograms. That gets you 5,150 total milligrams. You need to divide by 24 milligram concentration, and you should come up with a total volume of 214.6 milliliters. We'll put that 214.6 into the total volume section, multiply by 60, but we have to divide by minutes, but we're talking about 4 hours now. So 4 hours times 60 minutes is 240 minutes. So if you divide 214.6 times 60 divided by 240, you should come up with 53.5 milliliters per hour. Just one more stage to go. Press pause now if you want to do your calculations yourself, and then come back when you're ready to look at the answer. For stage 3 of the dosing, we're going to take 100 milligrams times 103 kilogram weight, and that gives us 10,300 total milligrams to be administered, divided by 24 milligrams per milliliter concentration. That gives us 429.2 milliliters that has to be given over 16 hours. 16 hours is 960 minutes. So if we take 429.2 times 60 divided by 960 minutes, we get 26.8 milliliters per hour for the final dosing. If you got the same or very close answers to that, you're doing great. But have you noticed the problem? The problem is the nurse only gave us 6 grams of Mucomyst. So how are we going to fix this? One way would be to mix up 5 or 6 bags, and then we can leave all the numbers the same and just switch out the bags when we run out of fluid. The other way to fix this would be to ask for 4 or 5 more vials and put them all into the same bag and just do the math and calculate the new concentration. Either one of those solutions would fix the problem, and it's entirely up to you how you would handle that in the field. With strong math skills and practice, either way, you got this handled. See you on the next one.